Hello, welcome to Stage of Java conference. This is the recording for 11th of February 2022. And my name is Wolfgang. Hi again. I'm part of the global Java team working on Java technology and focused on GraalVM, the usage in projects with customers and on their architecture. And I'm some part of my work is working with the Java user groups and of course sometimes talking at conferences like this. So hello again from my side here from Frankfurt, Germany. The first part is the disclaimer here, the safe harbor statement. And you see GraalVM, the native image, got an early adopter state, and this technology is supported by us, but it's mentioned here because the innovation is moving fast week by week, and this got the remarkable early adopter technology state, but it's supported for running the native image here. I prepared for the talk the agenda. And first step is about to mention how you can obtain the GraalVM Enterprise Edition. You need to have the Java SE subscription. The second part is an introduction into the enterprise technology of GraalVM with the three major features. It's a just-in-time compiler, the polyglot support for multiple languages, and the native image itself to create one and to see the native image performance. And then we will look after the enterprise components itself and to have a summary at the end of the talk. On the first step, you need to have for any production purpose of GraalVM the Java SE subscription. So any other use of the Oracle Technology Network license, it's called OTN license, GraalVM for development purpose, developing a prototype or testing it, it's for free. And once you put the GraalVM Enterprise into production, you need to have the Java SE subscription. Otherwise, you can test it before production within the OTN license for free. To cover GraalVM Enterprise, there are three major features here. The first one is a JIT compiler. The JIT compiler, it's an optimized compiler, and we just replace the C2 compiler based on Hotspot with the alternative GraalVM compiler. And Java itself got backward compatibility, it's guaranteed, and GraalVM, it's 100% compatible to Java itself. The second part in the middle here is embracing different languages, dynamically typed languages like JavaScript, other languages, Python, Kotlin, Ruby, R, Scala, all the JVM languages itself, of course, and here the low-level VM toolchain with C, C++ as well, and supporting this in different flavors with the Graal compiler. These are interpreted languages. Some of them are experimental, like Python, though you need to be aware of that there are some restrictions. And the third part here, you see it's a major feature. It's the creation of a native image with the ahead-of-time capability. And therefore, you can build microservices based on microservice frameworks. And these microservices often use a single-page application with JavaScript. So you can combine the second part here in the middle with a JavaScript front end with using the microservice here running on a native image, and both as a tiny piece of code and having the benefit of 100 times better startup times than before without native image, and increasing the usage, of course, and the throughput. And we have less memory consumption, 5 times less memory consumption here with the native image. We will cover this later on. Going back to the first step, if you think about an application server, it's easier to change the runtime in some minutes, and you got major improvements with a tiny change, just replacing the runtime here with GraalVM. And we have several opportunities here. We did replacing this with standalone application based on Java, all the different application server vendors, and even this is certified with WebLogic. You need to have the GraalVM Enterprise, it's certified, and then you can achieve much better results. And overall, it's about 10% possible for all these kind of different flavor applications based on Java. And then you can go on for the architecture level and embracing other applications like Tomcat, microprofile based applications, and of course as well the Spring Boot applications. And this is covered by the native image. There are several improvements to build a native image. This is more sophisticated. You need to spend much more time and effort into creating a native image. Then it's just the easy way to replace the runtime path with a JIT mode. But you can combine in a native image a JIT mode application which resides in the native image, and we will see this later on. So I mentioned this, the hotspot VM, the JIT compiler is written, the C2 compiler is written in C++, as all of the components of the hotspot VM. Java exists for 27 years this year. And with GraalVM, we just replace the C2 compiler. And this was possible because of the JVM compiler interface, got the abstraction layer here possible. And this were in year 2012. And our founder of the GraalVM, Thomas Wörtinger, is the lead of the Oracle Labs of GraalVM technology, and having this done in the past as the science work on university in Austria, and this made it possible to change the compiler technology with GraalVM. GraalVM itself is written in Java. It's proven for performance, and this was released as production ready 3 years ago almost, and it was 11th of May 2019. And though we had this experience and it's moving fast on technology innovation and getting more and more stuff embraced, though you see the polyglot capabilities of GraalVM. Here we see JavaScript, R, Ruby, and the C++ low-level VM toolchain. They are based on the language interpretation framework Truffle, and Truffle made it possible to do the mapping for several languages. So we did it many times for many languages, though there's a lot of very high sophisticated practice in doing that, mapping languages and do the interpretation of that in the Truffle language implementation framework and putting that stuff to the Graal layer, the Graal compiler, and underneath you see here the JVM compiler interface. This is based on hotspot and that makes it possible that you can use these components. The other languages, as named as a JVM language, they reside directly on the JVM, like Java itself, or Scala, or Kotlin. And for benchmark scenarios, Scala had a lot of good capabilities to do inlining optimization, and that is much more optimistic. Though in benchmarks we achieve about 50%, and for Java it's about 40%. Depends on the inlining capability. Yeah, and once it's optimized, then you see really good results. To mention it, the Twitter application, more than 500 millions using this kind of applications. They use a JIT compiler of GraalVM with an own team. Yeah, and they used to have many years ago the community edition with an own high-class engineering team maintaining this, and this is of course another benefit that these people are working with GraalVM technology. And to show this here in a moment, I will switch to the GraalVM project advisory board here to see how many companies and what kind of companies are working with GraalVM technology. And there's several OpenJDK downstream vendors. Yeah, there's another company building GraalVM on the embedded side. It's called Microdoc in Munich. They're working on the worldwide embedded stuff, and they can use GraalVM and Java in all flavors and build this kind of technology for specific chipsets like NVIDIA or other smaller embedded chipsets. Though Chris Seaton, a former colleague from the Oracle Labs, he is working for Shopify, Canadian e-commerce supplier, and he's implementing the Ruby language, Truffle Ruby, and he's doing that stuff and contributing back for the language Ruby based on Truffle. And here we saw the Micronaut framework making usage of GraalVM technology. We had Graham Roche, former here, developing this. He joins the Oracle Labs, and Ivan Lopez successing this work here. And as well, we have Gluon here working with GraalVM on the JavaFX user interface side on Java Fat Client technology. Even Red Hat is working here with GraalVM on Quarkus, on the microservice framework, Neo4j, here to mention, working with graph databases with GraalVM, as well Amazon taking care about Graal technology, and their counterpart in China with Alibaba as well. And largely to mention here, Sebastian Delois as a Spring committer, and he is working on Spring Native. Spring Native will get this whole stuff embracing GraalVM as a native image, and this comes as described in the milestones of Spring into Spring Boot, and then it's a regular observed technology of Spring Boot, and at the moment it's a separate treated project with Spring Native and GraalVM. Thomas Wertinger itself, the founder I mentioned, he coordinates all that stuff, and it's a large team at the Oracle Labs taking care about the individual capabilities. I mentioned Twitter, former the JVM engineer Chris Tullinger had the lead over many years introducing GraalVM, the community edition, into production many years ago, 5 years ago. So, and the ARM technology here is using as well Graal compiler technology for their architecture on Linux and so on. So we can take a look into both kind of flavors. Last week we've got an update for the version 22, and in the year before we count on calendar year, it's 21 for year 21, and we have 3 releases after GA. So means an update means 21.1.2.3, and 3 is the LTS version. The performance it's equal from 22 to 21.3. My recommendation at this time in the year is to use 21.3 for production environments, because it's got the same performance, and for trials of developers you should go for the newer release 22, which is today just a week old here. And for the download stuff, I will show this later on. You see, if you use the Enterprise edition here, I hide menu. You can choose the GraalVM Enterprise edition with the aligning Java version. It could be 11 or 17, yeah. And 11, it's the mature LTS release of Java, and as well you can take a look at 17. For my experience, if you look out for existing customer projects coming from JDK 8, it's worthwhile first to use the GraalVM edition 21.3 based on Java 8 and see what the performance difference is on that level, on 8 compared 8 to 8 with GraalVM. What's the difference? And then you can go to 11. That is the recommendation for mission critical applications, GraalVM Enterprise 21.3 based on JDK 11. And here you can choose the appropriate operating system. And now you see the difference here between Linux on x86 or on ARC 64. Both are 64-bit architecture, and the underlying here, it's ARM devices covered itself. So all these different parts are mentioned in the documentation. On an installation guide, you see what about the Enterprise Core engine is. Yeah, what is the native image? Here it says it's fully supported, as mentioned before. Despite it's an early adopter state. This is what I meant in the disclaimer here. And you find a lot of different language toolchain plugins and other plugins you can download separate and install it, and as well you can upgrade your version itself. So if we take a look at at the Java installation and ask it, what's your name, what's your version? So it's GraalVM Enterprise Edition 22, the GA build here from mid of January, and it's based on JDK 11, and the update it's 14, and it's an LTS release, and it's got the JVM compiler interface abstraction layer. Underneath here, it's the hotspot VM, it's the Oracle JDK, and this means it goes aligned with the Enterprise Edition here. So for the Community Edition, you have the same E replaced by C, and you have the OpenJDK here. It's the same flavor, but you can't support the OpenJDK or the community edition or both. So you can only support it once the software is known and marked as an enterprise edition here. So if we look into the components, what does it have? The GraalVM Core Edition, here you see it's supported on my machine. It's a macOS machine, and we have here the experimental part of Java on Truffle, which was formerly experimental. Now it's supported here, means Java on Truffle itself as a JVM language can run. It's a code component ID name Espresso, and it's a meta circular thing that you can interpret Java itself on GraalVM. But in the first time, and in the first part, you can run it directly as a JVM language like Scala or Kotlin directly. So JavaScript here, it's supported, and the whole low-level VM toolchain here is supported as well. Native image got the state, but stability, it's early adopter because it changed so fast of the technology innovation. Node.js obviously is supported, and all the others are marked as experimental, like Python, Ruby, and WebAssembly here in this case. If I take a look at the low-level version, I see it's version 12 based on an enterprise edition as well, the native image here, and I can check this. If I have to obtain more information about this low-level VM toolchain, what is necessary here to have for the whole native image on that level, I see stability is supported here, and we see several points of information on the command line interface. Last thing I would mention here is the version for GraalVM itself. And you see the several tools which need to be here, for instance, to get scripted agents, to cover other classes and or code coverage, and all what about processor unit, and to support the debug protocol server and heap allocation, and to monitor it and inspect several things here, and trace memory and sandboxing feature. It's an enterprise feature, embracing other code here, for instance, for Visual Studio Code. And I come back here to the presentation. And so I mentioned this, you will find this on the website. It's still mentioned the Community Edition 21, what is production ready by platform. Though you see this, if you decide to use a developer project for GraalVM, I would recommend it to use macOS, MacBook Pro fully equipped. This is very useful for creating a native image. You have enough power on that. On the Windows machine, you need to take care on your own about the whole low-level VM toolchain. The compiler set for Microsoft, they need to be installed separately. And so I could recommend macOS and Linux for developer machines, and of course running Linux and into production. That would be best good decision to make. And but as well, Windows under these conditions here what is shown is supported or not available or experimental. Python, it's even not available on a Windows machine, though stay away for this. If you want to go for Python, which is experimental, you should go here with macOS or Linux. To explain it further here, what are the benefits here for the Enterprise Edition? Means the yellow line here is the JIT compiler characteristic. It starts cold, and with the time it's getting better and getting more throughput, and then matching the red line, it's faster on that way and gaining 60% more than the red line. What is the red line? The red line is the native image. The native image starts directly with the warm throughput here, and it does not have a cold start. That means reduced startup times. This capability is needed by microservices. Of course, they just immediately want to start and want to have the throughput. But we need to get the native image learned, these 16% performance improvements from the JIT compiler. How does the native image learn the behavior of a warm ramp-up phase of the JIT compiler mode? This is possible with the profile-guided optimization. So the native image has the characteristics, a high startup speed and small packaging, put it in Docker, and we're working on this. So, and it got a low memory footprint, 5 times less memory consumption than without ahead of time compilation, without a native image. The just-in-time compiler characteristics got more peak throughput, is 80% more, and reduced latency on that level. So with the profile-guided optimization, the ahead-of-time compilation characteristics learn about this and can adopt this. Means we run the native image with the workload and we retrieve profiling data. Retrieving this with the option -PGO, with the -PGO option, creating a native image, we retrieving profiling data. Then we create a second native image with the knowledge of the profiling data. And with that, we have the experience of the workload characteristics for the native image. Then we got this up to the peak throughput, which was possible by the just-in-time compiler. So we had the maximum of performance with the profile-guided optimization. This is as well an enterprise feature, the PGO option. And what are the differences between Community Edition and Enterprise Edition? The Enterprise Edition got much more better compiler technology on the JIT compiler side, and as well better compiler on the native image side, even profile-guided optimization, and better usage of garbage-first garbage collectors, and it could have separate heaps, isolated heaps here, and meaning these things are much better structured here. And if just make here the next point with the IDE, hopefully it starts here with Visual Studio Code. Yes, it does. And if you embrace JavaScript as a language here into your environment, well structured, and you can use the GraalVM extensions. Means you have the server debug protocol here included with the plugin for Visual Studio Code, and it makes it possible to use the extensions here, and all these components are obviously connected, aligned to the IDE. Yeah, and you have the same here. What I did before, I just do it here on the terminal. Yeah, and want the hello polyglot. So it means Java and JavaScript. So you can structure both code areas, well structure this into your environment. And here I need to hide the floating menu controls. And though you see the code is structured, it's not mixed up, and the Enterprise edition of GraalVM could sandbox this code. You can limit it. You can limit your processor capacity or your memory capacity. So no one could exploit your existing data or count data in internal systems. Yeah, no one could exploit this here getting entered into this applications, because they can limit it, can be limited, and can be sandbox on processor capacity and on memory. And as well, the last point I need to mention here with the native image and the polyglot capability to run foreign code, C++ code. It could be a managed execution that you can really restrict the foreign code, like running C code under a managed execution condition. Yeah, this means the whole low-level VM bitcode support is bigger with a managed execution at the Enterprise edition. These are the major differences here. So coming to the native image means observing all the reachable code in jar files, libraries, classes, everything which could be executed and reachable is observed and put into a point-to analysis, and it would be iterated, and we will see this in a few moments. And then for each platform separate need to be an individual executable to be built, created, though there is a native image for Linux and for Windows and for macOS. You can't cross-compile it for all the operating language platforms itself. Yeah, you need to do this separate. Yeah, because you have shared object libraries here with Linux, or DLLs on Windows, or you have dynamic libs on macOS. And this means more effort to create a native image. Means the compiler got many configurations looking into the application, a jar application, and a JavaScript part, as I mentioned earlier. And this needs to be observed, and the analysts need to run over this in a point-to analysis, and then the ahead of time compilation builds the native image with your dedicated application. And it could include the JavaScript area, and as well the whole stuff running on a JIT compiler inside the native image as a self-executable file binary. What does it in detail here? The input is having all the classes from the application. If we can't see all the code, we can't really do an aggressive optimization. This is not possible. We need to see all the different unused classes, methods, and fields. Then they could be removed. And there is not the possibility to have a dynamic class loading afterwards. There's no reflection. We need to see everything, all the bytecode is necessary to have it at runtime. And then you see all the possible errors at build time. And at runtime, it's there. The workload is running because the work is done at build time. And then with the iteration, the point-to analysis, with all the initializations, the snapshotting, the head of time compilation is done here with the code in the text section, and the image heap is written into the image heap in a data section here as described. So we shift the border without GraalVM compiling all the sources. We shift this border from build time, runtime with GraalVM to a configuration file in this case as a default. We need to see all the loaded classes before. Then we could reach this. For Spring, for instance, we can collect the necessary classes for the indexing and all that stuff at build time. So therefore, a configuration file is created by within the agent technology, automated collected information, and load this run configuration file for build time, and then the runtime just needs to have the workload here. So I mentioned here the profile guided optimization before, having the argument PGO instrument, creating an instrumented binary, the profile data, then running a second PGO, and having the optimized binary. If we go back to the console here, we see this, and that file earlier in the moment. And in this directory, I have a simple hello world to show it in the matter of time. You see it here, and there is my hello world, just to see what's in here. So just saying hello and the date, means time world. So takes 0.2 seconds here to run this with truffle, for instance, means Java minus truffle and my hello world. Again, it takes a little bit longer because it is got the interpreted layer. Of course, it's faster than it was before because we use release 22. Then it was with 21.3 at this time, a little bit faster. That must be the reason, because it changed state from experimental from 21 to 22 as stable here. And if I use the native image, it's in lower letters, it just not really counts here. If I run it, it goes very fast. Now, and lastly, if I look into the file again, I want to run the native image here to see it. My hello world again, and therefore we worked on this that we get more information, and compared to 21, it's half the time in creating this native image, and you see a lot of more information, performing analysis, which classes are reachable fields methods, and then you see building the universe, passing the methods, inlining and compiling and creating the image. And it took here in 22 seconds here overall, and it's faster than with 21.3 in this version, much faster, and you get more information from the command line interface here. The top 10 packages in the code areas from the Java language, Java util, and from GNI calls, core generation scavenge here to clean it up, Java mass and GNI functions, Java concurrent libraries, the concurrent stuff, and of course time, I used it, of course, and the substrate VM, which is the core engine for the head of time compiler here on the Graal engine. So you have a lot of informations, debugging informations are even as well possible with a report directory. You can print analysis, a call tree, and describing a call tree from others, and having all this information. So we will see here it's for megabytes. In this version, it's three times tinier than it was before. And of course, if I run it again, it's the same size, same amount of performance as it was before. Yeah, and of course, I can shrink it hopefully here with Packer tool, and should be a little bit back. Yeah, it is better. And to run it again, it slightly got a friction of some friction of seconds here, 0.04 seconds here. Doesn't mean that's really good payoff with the Packer to put it in a smaller area here. So in terms of the time, I need to wrap it up here and to close it for the recording. Here I want to thank you everyone for watching this at the conference, and remember the three major features here: JIT compiler ahead of time compilation, the polyglot capability, and please try it at your own application, and then you see your own measurements. Thanks a lot, and goodbye to everyone listening to that meeting. Bye.